So today we're going to do question number 13 of our NeetCode playlist, which is container with most water. It is 11 question of LeetCode. So first of all, what is a container? Let's say we have a table, okay? Now if I throw water here, then the water will fall down, obviously. So let's say I put a ball here, a small ball, anything, any object. Now if I put water here, water will not go beyond this, but it will still flow this way, okay? So now what can I do? Let's say I add another ball. Now if I add water here, it will contain here, it will not flow out of it. That's why it is called container. Okay. So now we know for a container to contain water, we need at least two walls and obviously the ground, which is table here. So three walls basically. We can also have four, but then we cannot fill it because it is closed. We have to keep it open and then fill it from the above. So now we know that a container can contain water this way if we have two walls. Now let's say if it is 5, 5 and 4, it is a square container. Okay. So now when you fill water, it will fill, let's say it is 1 unit. So let's say this is also 5. So 1, 2, 3, 4, 5 units water here, and then 5 times because this is 5 height and 5 width. So the water will be 5 into 5 equal to 25. Let's say if it was 4, 4 and 5, then 5 units 4 times because height is 4. So the water formula will be 5 into 4 equal to 20 units. So from this we can tell that the total water a container can contain, the formula for that is equal to width into height. Okay, let me write it here so that we can remember this for the future approaches. uh, Water equal to width into height for any container. Okay, now let's say if this height was 5 and this was 7 and this is 4. Now the water, what should be formula, 5 into 4 or 7 into 4? Let's take 7 into 4 and we get 28. That means water can fill up to this point 7 and 4 times. But we can see that this falls only till 5 centimeter. So that means the water will fall down from here. The water cannot contain this way. But if we take 5 instead, if we take it is 7, it is bigger than 5, so we only take the 5 part of it. So we get 5 into 4 equal to 20. If we fill water this way, then the water will not fall this in this direction and will not fall in this way as well. So that means if any two walls are given, the formula is the width into the minimum height of the two. So we change the formula here. We get minimum of h1 and h2, where h1 is one wall and h2 is another wall. Whatever is smaller, that will be a limiting factor. Okay. Now another thing to note, that if we have, let's say this is 3 and this is 4. Now if this is 7, the water will be 3 into 4 equal to 12. 3 into 4 equal to 12. Even if it was 17, doesn't matter because the smaller wall is 3 and width is 4. So the water will still be 3 into 4 equal to 12. So that means if we have one limiting factor, no matter how high the other wall is, we will only take that as a limiting factor, as a main reason we will take the water which multiplied by width. Okay. So now let's see what the question says. Question says we have an array of different heights, different walls basically. Okay. So let's say the walls are like this way. Based on the size of the walls, the values also differ. Let's say this is 1, 7, and 4, 3, 6, 8, and 5. Okay. So now the question says we can take any two walls and pretend that the others doesn't exist. Okay. So let's say if I take this one, 1 and 6, that means forget these three lines and between this, tell me how much water can we contain. So the formula will be width is 1, 2, 3, 4. To get in the base of the index, let's say index are 0, 1, 3, 4, 5, 6. You can see that this is index 0 and this is index 4. So 4 minus 0 equal to 4. 1, 2, 3, 4. That means for any j and I index, the width equal to j minus I. Okay. Now how to get height? We have this value 1 and we have this value 6. The minimum is 1, so the water will be 1 into 6, height into width. That means minimum of height of both into the width. Okay. So now again we change the formula. We get j minus I, which is the width and the minimum height, obviously. So now the question says, out of this array, we will be given this array 1, 7, 4, 3, 6, 8, 5. And out of this array, we have to tell that how much water can the best container contain. So let's try the brute force. The brute force says, for let's say the I is here. For this I, we check j many times. And for each ij, we take this value and store it in the max variable whenever we find a better answer. Okay. So now this is done. Now take this I and then j, I and all the j's and I all the j's. So this is the O of n square brute force approach and O of 1 time space, because we check each j for each I. That means there are 5 lines, 5 towers and 5. So we do 5 checks for each tower. So that means 5 into 5 equal to 25. Okay. 5 and 5, 25 times we check for 5 lines. Obviously, this is not good. We have to think of something better. So let's take another example, and now we will try the optimal way. Let's say the array is 1862, 1862, and 54837. 54837. We will add the index as well so that we can compare the distance. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is the array. Let me make a bracket so that you don't get confused. Now let's make the towers. 1 is the smallest, so 1. And then 2 is a little bit bigger. Then 4 is double of this. Uh, okay, now it's good. 1, 2, 4. 3 is a little bit smaller. And then 5 is a little bit bigger. 6 is even bigger. And then 7 is even bigger than this. And 8 is the highest. So 8 we have 2 times. Okay. So now we know to get to get water of a container, we do width into height. So to get more water, we need either more width or more height. So let's see in this array, the maximum width we can get is if we take this shower and this shower, because the width is 8 minus 0 equal to 8. So the 8 is the maximum width. We take this in the starting. So that means we give the 2-point approach. I is here and j is here. Okay. So now the width is 8. That means this is fixed as 8. And now we take minimum of height, 1 and 7. Minimum is 1, obviously. No matter how big this one is, even if it was 80 or 90 or 100, we still take this as the height because this is the minimum. So we get minimum height equal to 1 equal to 8. That means let's store the water somewhere. Let me write this again. J minus I into minimum of H1 and H2. Okay. Now we store max equal to 0. We got 8. That means better answer. So we store 8. Now we can either move I, either move J as usual as 2-point approach. But even if we move this and we get a higher number, let's assume this was 13 instead. Let's assume. So even if we get 13, the weight is decreased now as width was 8 and now it's 7. That means the water will be less. So to compensate for this, we need a better height. But even if we have 13, this is still 1. And this is the factor that tells us how much water we can get. This is a limiting factor. So when we don't want to move this one, we need to increase this one because we need a better answer as a minimum height. If we get 8, so that 8 is bigger, that is a different case. But still, we want something better than 1. It doesn't matter 7 is big or not. So we move I, obviously. So now we have I equal to here. Now, the width is decreased by 1 because index 8 and index 1, 8 minus 1 equal to 7. And the height, 8 and 7, minimum is 7. Now this is a limiting factor. No matter how big this one is, we just care about this one because this will tell us how much water can be contained. So we do 7 minus 7 into 7 equal to 49. We get 8, we had 8 and we now get 49. So that means this is the best answer we have so far. Okay. Now again, I and J. If we move this, even if we get a bigger tower, this one is still the main factor that tells us how much water we can contain. So we move this one to get in hope to get a better answer. Okay. Now we think we might get better one, but we actually got worse. So now again, width is decreased by 1 as well. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, which is 7 minus 1 equal to 6. So now width is 6 and minimum height is 8 and 3. Minimum is 3, limiting factor. So we do 6 into 3 equal to, we get 18. We have 49, we now get 18. So that means this is not the better answer. So we do not save it as anywhere. Let me erase this, do not get confused. Now again, I and J, this moving this won't matter because we need better J. J is smaller. So we increase J. Now we get the best one so far, the best height so far, which is 8 and 8. The width is 1, 2, 3, 4, 5. That means 6 minus 1 equal to 5. And minimum is we can take any one because both are same. So we take 8. We get 40. We already have 49. We now have 40. That means it is still the best answer. Now you might say the height has been increased. Earlier we had 8 and 7. And now we have 8 and 8. So why is it not better answer? It is because we have increased the height by 1 unit, but the width has been decreased by 2 units since then, since we get 7. So that means in the overall net, if we do net profit, we get a negative profit. Okay. So now I is at 8, J is at 8. Now we again want to move. Now we can move anyone because both are equal. We need a better, we need better than 8. Any one tower is okay. So let's see if we move this one, I. Now we have 6 minus 2 equal to 4. 4 is the width. 1, 2, 3, 4. And the minimum is 6. So that is a limiting factor. We do 4 into 6 equal to 24. Not better. So we remove it. We don't consider this as an answer. Now again, 6 and 8. 8 says there only because it is a bigger one. We need a better I. Now I is here. We actually got a worse I, but doesn't matter. Okay, we still go on. Now we have 6 minus 3 equal to 3 is the width. And minimum of the 2 is 2. So we got 6. Again, we have better answer. So forget this. Now 8 and 2, we move the smaller one, I. 5 and 8, that means minimum is 5 and width is 6 minus 4 equal to 2. We got 10, we have better answer. So forget this one as well. Now again, 5 and 8, we move the smaller one. So now I is at 4, j is at 8, and distance is only 1. Only one distance apart they are. So we do 1 into 4 and smaller is 4. So we do 1 into 4 equal to 4. Again, we have better answer. So we again remove this and move it. Now I and j are at same point. If we have this container, this cannot take water because this is one line. We need two lines at least to store water. So we now stop the loop. So now the answer is 49. This is the best answer so far. Now let me code it up also to get you a better idea. We were able to do it in O of n because we just did one loop. Either I will move till here and j stays here always if j is let's say 100 and these are 1, 2, 8, 9, 4, 7. Either or in other case I will stay here and j will keep moving, or maybe in the third case I will move till here and j will move till here, that like we did in this example. So in any case the O of n is the max complexity because this will do only one loop, either one loop or half a loop each. Okay, so now let me code it up. The code is very simple. It is a medium question LeetCode, but it is not that hard. We do I equal to 0, j equal to n minus 1. N is the length of the array, okay? And we do water equal to, no, we do max equal to 0 because we don't have any answer yet. And we also do width equal to 0. Now we say while I less than j. If they are equal, then stop. So we just do I less than j. Then we take h1 equal to heights of I, h2 equal to heights of j, the array is heights, and we do w equal to j minus I. This is the width. Okay. So now two cases. If h1 less than h2 and else. Let's say keep it equal because if equal doesn't matter, we can put it here or here. So first of all, the water will be width into minimum is h1 because it is smaller. So we do water into h1. In this case, h2 is smaller. So we do water equal to width, say same, and h2 is smaller. Now we got water in both cases. Now we do I plus plus because h1 was smaller, so we move h1. So we move I. In this case, h2 smaller, that means h2 smaller and h1 greater. So we move j this in this direction. So we do j minus minus, and in the end we do max equal to math dot max in Java, max comma water. This is a loop. It will keep going while this condition is true, and at the end we get the best answer in this variable. We were able to do it in O of n space and O of n time and O of n space. Okay, that is it for today. Thanks for watching, and I will see you in the next video.